Hey guys, in this video we're going to be looking at parent functions, and in part 2 of this video we're going to look at some examples to do with parent functions and we're going to add in transformations. So in this video we're just going to talk about what a parent function is and talk about 4 of our parent functions that we're going to see in Algebra 2, and then in the next video we'll kind of look at some examples and kind of do examples and teach a little bit with what transformations are. So be sure to go on and watch that second video for more information on this. But let's dive right in. So we have 4 parent functions, and all a parent function is it's like a basic function that represents an entire family of functions. So we have 4 that we're going to look at, and if we look right here, this is the family name of each function. So that's just what we call each function. So we have 4. We have our constant function, our linear function, our absolute value function, and our quadratic function. The next line tells us the rule for each, and you're really going to want to memorize these. But a rule is just a equation that represents a function. So if we look at the first one, our constant function is always going to be f of x equals 1. It's just f of x equals 1. And all of these rules or equations are going to start with f of x. And remember, f of x, sometimes you can write it as y. It's a function of x, but a lot of times you'll see that represented as y. So you can think of it as f of x equals, or you can think of it as y equals. So f of x equals 1 is our constant function. Our linear function, f of x equals x, so we're replacing the 1 with an x. Our absolute value function will be f of x equals the absolute value of x. So that's what those little bars mean right here. The little bars mean absolute value. Okay? And then our quadratic function is going to be f of x equals x squared. So remember, quadratic is something squared. All right, so think about that, x squared for your quadratics. Now the next thing you're going to want to know is what these graphs look like. And again, you want to memorize this. You want to be able to look at a graph and say, that's a constant function, or that's a linear function. Let's look at constant and linear. So our constant function, of course, is right here, and then our linear function is right here. What is the difference between those two? You can see they're both straight lines, but one of them doesn't go up or down, but it remains at a constant level, or a constant y value. And that's really where it gets its name. In fact, if you look at the equation up above for the constant function, notice that it's always equal to 1. It's constantly 1. So y, or f of x, will always equal 1. And we can see that in the graph. It just continues to be 1 forever. It doesn't matter how far to the left or how far to the right you go. It's always equal to 1. Whereas the linear function, it changes. It's also a straight line. In fact, really, the constant function is just a special form of the linear function. Because they're both straight lines. So a linear function is a straight line, but it doesn't have to be constant. It doesn't have to be constant. Absolute value is a little bit different. Check this one out. The absolute value function looks like a V. So it's not a straight line, because right there at the origin it looks like it turns 90 degrees and kind of goes in a different direction. So your absolute value function will always be 2 straight lines that form a V. And then your quadratic function will always kind of look like a parabola or a U. Okay? So the quadratic function will always be a curving line that looks a little bit like, or is actually a parabola. So it's a parabolic function there. All right, now the next thing that's important to look at here is what the domain and what the range is for each function. So remember, the domain is all of the x values. So I'm going to write that over here, the x values. All right, and the range is all of the y values, So domain is all your x values, range is all your y values. So if we look at the graph for the constant function, our domain's all the x values. Notice that it starts out way over here on the left side, like way over there, like negative infinity, and then it continues all the way to the right, to positive infinity. So really, it includes all of the x values that there are. So we say that the domain for that function is all real numbers. All real numbers. Now the range is different though. That's the y values. If you'll notice, our function never goes down here. And it never goes up here. In fact, if we look at all of the y values, it looks like there's only one y value that this function goes through, and that's right there. It doesn't go up or down. So it always stays at that constant level. So our range for the constant function is just going to be 1. Y equals 1. It's only one number. Okay. You might notice, you might connect that the range turns out also to be what the function is equal to. And so you can tell that with constant functions, anytime you're trying to figure out the range, it's always just going to be equal to whatever the rule is equal to for constant functions. Okay, let's look at our linear function now. So we're going to look at let's switch up the colors a little bit here. We're going to look at this graph. Notice that the domain, we go to the left forever, so all the way out to negative infinity, because we continue to go on down this way. So it continues to go to the left forever, and also continues to go to the right forever. So from negative infinity to positive infinity includes all the x values, so our domain is all real numbers. But also notice that it goes up forever, and it also goes down forever. It continues to go upward, continues to go downward, so our range is also going to be all the real numbers. All right, okay, let's go back to our absolute value. With our absolute value, what is the domain? The domain, notice it goes to the left forever, goes to the right forever, so our domain is going to be all real numbers. It's going to be every number. There isn't an x value where that graph doesn't go through. But what about the y values? Notice that it never goes into the negatives. Notice that this function never goes down here anywhere. So we say that the y values start at 0, it looks like, and then they go up forever. So we would say that the range is going to be y equals greater than or equal, or y is greater than or equal to 0. It starts at 0, and then it goes up forever. All right, what about the quadratic? This one actually is very similar. Notice, it looks like it continues to go to the left slowly, but it looks like it continues to go to the left forever, and it looks like it continues to go to the right forever. So our domain is going to be all real numbers. And then again, it looks like it starts at 0 for our range, and then moves upward. But it doesn't ever look like it goes downward on this one. So our range for this one is going to be y is greater than or equal to 0. Okay, so that's important. You need to remember what those four parent functions are: the constant, linear, absolute value, and quadratic. Be able to recognize what their rules are. Be able to recognize what the graph is. And then just be able to, if you can get the graph, then you should be able to determine what the domain and the range is for each one of those functions, knowing the domain is just the x values and the range is just the y values. Well, guys, I hope you all enjoyed that video. And in the next video, we're going to do kind of a part 2. We're going to look at some examples with parent functions, and we're going to look at something called a transformation and how we can identify transformations with different functions. Anyway, thanks guys for watching this video, and I'll see you in the next one.